Hello again, 3U and 4C chemistry students. Today's lesson is going to be a good review of a whole bunch of stuff we've been doing. We're going to be doing stoichiometry, and as you can see, we're doing solution stoichiometry, meaning that now we have another way of getting to that very critical number of moles that you always need to get to in stoichiometry. Because once you have moles of something, we can use that mole ratio from the coefficients in the balanced reaction to hop from one substance to another. Now, from a couple lessons ago, we worked with this formula up here in the corner, which I have a magic triangle for, which says that moles are equal to concentration multiplied by volume, or that concentration of a solution is moles divided by volume, etc. So by using that formula, if something in our balanced equation is a solution, which you can totally recognize because it'll have AQ after it. So in my first example, I'm just pointing out that there's a whole bunch of aqueous solutions, which means a solute has been dissolved in water. So if something is a solution, we now have another little method in our toolbox of how to figure out a number of moles. And that is using some variation of this formula, which in this case it is set up for N, which is moles, is concentration times volume. Now, sometimes the question might ask us to later figure out, what is the concentration of something, or what is the volume of a solution you would need. And in that case, you could use these other variations of the same formula, which have just been rearranged differently, and the magic triangle can help you do that. Okay, so lots of review, and that might be good because I know some people are still struggling, with either concentration or with stoichiometry. So this is sort of a good lesson to hopefully get everybody caught up a bit. Okay, so first question. 10 millimeters of phosphoric acid is reacted completely with 182 millimeters of a 0.259 mole per liter solution of sodium hydroxide. They want us to calculate the concentration of the acid, which we can see is a solution, so it will have a concentration, and finally figure out the mass of water that we would make. So just like all stoichiometry, the first thing I want you to do is write down everything you're given and everything you need. So 10 mils of phosphoric acid is a volume. I'm putting it here. Okay, now something else that you should remember, or I'm going to review right now, is when we're using our concentration formula for molar concentration, it's always moles per liter, which means the volume has to be in liters. So right away, I am going to change this into liters. And I'm in milliliters right now. So 1,000 milliliters is 1 liter, which means I need to divide 10 by 1,000. And I'm going to get 0.010 liters. And I'm squishing over into my next column here a bit. Okay. So it is reacted with 182, whoops, I should put volume equals, sorry about that. Volume equals 182 milliliters, which again, we're going to divide by 1,000, so 0.182 liters. And the concentration of this is 0.259 moles per liter. Okay. So one of the questions, question A, wants us to figure out the concentration of the phosphoric acid. That is question A. Question B wants to know what mass of water are we going to make. So again, I'm just off a little bit here. I'm taking up too much space. So question is mass for water. And right off the hop, I'm going to figure out the molar mass of water because I know I'm going to need that. And you might have it memorized by now because you use it so often with water, but 18.02 grams per mole. All right, now you might be thinking, oh my goodness, is this a limiting reagent problem because we have, information about both reactants? The answer is no, because the key is it said reacted completely, which means all of this reactant and all of this reactant got completely and perfectly used up with each other, and therefore there's no leftovers. So we don't have to test out two things in this particular question. So anytime you see reacted completely, you know that everything is used up. Okay, so where can we start? We have one known piece of information about water, so that's not going to help us. We have one known information about the phosphoric acid, so can't do anything with that. But sodium hydroxide, we have a volume and a concentration. So guess what? This is the new stuff. You can figure out the moles. N equals concentration times volume. So as long as you have a starting point, away you go. And then the rest will fall into place. So 0.259 moles per liter, and the volume is 0.182 liters. And that is going to give us 0.0471 moles of sodium hydroxide. Okay, so that's how many moles of sodium hydroxide had to be dissolved in 0.182 liters in order to end up with a concentration of 0.259 moles per liter. Okay, so that's our starting point of stoichiometry. We have moles of something. So we're going to work towards question A first, which is something about the acid. And if we have moles of this base, the sodium hydroxide, we can now use our mole ratio. So I'm going to put moles of sodium hydroxide on the bottom and moles of acid on the top, because that's what I want. And I want to get rid of the sodium hydroxide. So then I look up to my balanced equation and I see that it is a 1:3 mole ratio. So solving that, moles of sodium hydroxide are going to go away, and I'm going to magically turn it into moles of phosphoric acid, which will be 0.0157. Oops, that's super messy. 157 moles of the acid. Okay, now let's look over here at the acid. We know its volume, 0.01 liters. We're asked for its concentration, and I have now solved its moles. So this little piece of information here, I'm going to drag it over here, and I'm going to add it to my column. So N is 0.0157 moles. And then look, we have V, we have N, we want C. Concentration is moles divided by volume. So 0.0157 mole divided by 0.010 liters. My concentration is 1.57 moles per liter. And that we can write, just to summarize here, concentration, but what is it of? Phosphoric acid. And if you put it in square brackets, then that says the concentration of phosphoric acid is that. Okay, that is part A. We have now solved what the concentration of that acid had to have been to completely react with the sodium hydroxide. All right, now for part B, we're supposed to figure out, okay, what mass of water are we actually making? All of this gets used up, all of this gets used up. It really doesn't matter which one of these we start with in terms of a number of moles. You would get the right answer either way. But I'm just going to start with the sodium hydroxide because that was the first thing we had calculated before. So I need a number of moles of something in order to start a stoichiometry problem, which is that's why you always try to solve that right off the start. Okay, so if I've got my moles of sodium hydroxide, I would like to turn that into moles of water because eventually I'm trying to get the mass of the water. So moles of sodium hydroxide on the bottom, moles of water on the top. Then I look, 3 to 3, which is going to just end up being 1, of course. So sodium hydroxide is going to disappear. And then we are going to have 0.0471 moles of water, but we want the mass. We've already got the molar mass ready to go. 1 mole of water on the bottom, 18.02 grams on the top, and you'll get 0.8487 grams. Now with sig digs, if you look back at the question, everything had 3, so maximum 3. So that means that 8 is going to turn into a 9, and that will be my grams of water. Okay, and I really should put that in a box too, because that was also a final answer for part A. Okay, so that's our first question. And as you can see, really no new learning in here, just a lot of combining of stuff we've learned, which I keep saying that's what chemistry is like. It's a lot of building on one concept after another. Okay, for our second question, which I think will also be valuable review, we are going to see in a minute that it is a limiting reagent problem. So why do we know that? Let's write down all the stuff we know. So 250 grams of copper. So here's copper, mass, 250 grams. Okay, it's reacted with 2.5 liters of a 3 mole per liter nitric acid solution. Here's nitric acid. So we've got volume, 2.5 liters. 3 moles per liter is a concentration, moles per liter. Wants to know the mass of hydrogen gas that we're going to make. Okay, so the reason you can tell that this is limiting reagent problem is nowhere does it say that everything is completely reacted with the other reactant. It just simply says you're going to have 250 grams of copper and you're going to have this much acid. How much hydrogen are you going to make? Which means one of those reactants is going to run out, and it's your job to figure out which one. All right, so again, old stoichiometry rules. As soon as you have M written at the top, either a given mass or a question mark, you better get the molar mass down. So from your periodic table, the molar mass of copper is 63.55 grams per mole. And hydrogen gas is 2 times 1.01, so 2.02 grams per mole. Okay, so at this point we need to test out both substances. Okay, so we're going to start with copper. I've got 250 grams, and I've got a molar mass, which I'm going to put the mass on the bottom to get rid of it. 1 mole of copper. Okay, now I'm going to do this one where we just don't do the answers as we go. We just keep putting the conversion factors that we're going to use. So at this point, grams would cancel. I would have moles of copper. This is when I can now change my moles of copper, which is 1 mole, into hydrogen. And that is also going to be 1 mole of hydrogen. Okay, so moles of copper is now gone. So now my answer would be in moles of hydrogen. And I'm just going to keep going and figure out what is the mass of hydrogen I can make. So 1 mole of hydrogen on the bottom, and it weighs 2.02 grams. That's now going to cancel. You are more than welcome to put your answer each time if you prefer that, if you find this more difficult. It does take up a lot less space, I find. Okay, so based on this, we could make 7.95 grams of hydrogen gas. But that is not necessarily the answer. It might be the answer. We have to find out what could we make with the nitric acid that was involved. Okay, so for HNO3, we have a volume and a concentration. So we can figure out the moles. So we've got 3 moles per liter times 2.5 liters. And that is going to give us 7.5 moles of nitric acid. Okay, so then again, now we have our moles of acid. Let's figure out how many moles of hydrogen that could yield us. So it's 2 moles of acid on the bottom because we want to cancel that. And that is going to give us 1 mole of hydrogen. Oops, not H2O, hydrogen. There we go. Okay, so our answer would be in moles of hydrogen at this point. So I'm just going to keep on going and say I know that 1 mole of hydrogen weighs 2.02 grams. And then starting back here, I'm going to take 7.5, I'm going to divide it by 2, I'm going to press equals, then I'm going to multiply by 2.02. And in so doing, I'm going to get 7.57 grams, which with this question, notice how we have some stuff that only had 2 sig digs. Up here we had 3, 4, 3. Here we've got 2, 2, and 3. We are actually only allowed 2. Okay, so based on the acid, we're going to make 7.6 grams of hydrogen. Based on the copper, we're going to make 7.95 grams of hydrogen. That is impossible. We can only make the least amount possible. So this is the real answer because this is the least product that we made. And that's why you just test them both out. In some questions we've done previously, we have just stopped when we had the moles, and then we compared the moles, and then whichever one was least, we did that final step of multiplying by the molar mass. But you can go right through and do full mass for both substances and then just figure out which one is the least. Either one works. So because 7.6 grams of hydrogen is the least amount of product, then that tells us that the nitric acid was the limiting reagent. Okay, so a lot of the same stuff, just notice we have another tool to get to moles. Okay, that is all for today. I hope that was helpful, and we'll see you next time.